Hey everybody, this is Mr. Munson, and we are in Unit 10, Transformations. This is going to be our first video of this section where we're going to learn some vocabulary words and some rules for the transformations. Some of the transformations that we're going to be dealing with that you've actually dealt with in previous years. We're going to look at reflections, rotations, translations, and dilations. Let's get started. Okay, so hopefully you have this piece of paper in front of you and you're ready to go. If not, just put me on pause, go down to the description box. It's in the box just below the video that you're watching. There should be a link to this document, and you can just open that up, print it, and start adding this text. Okay, so let me just kind of give you what's happening here. So in this column here, we're going to have some word or phrase that we're going to talk about. Then we're going to kind of have the mathematical rules and definition of that. And then in this one will be kind of in other words, maybe how we might say it in a regular plain English. Okay, so transformations. So transformations are basically a way of taking a point and mapping it to some other new location. Okay, now there are some exceptions to transformations that, or pieces of transformations where that doesn't happen. And as we go through it, you'll discover that. Okay, going over to the in other words area, we have transformations typically move an image's position or perspective. And it actually can even change its size. But right now we're looking at transformations that keep its size, the drawing size, but might change it by turning it, twisting it, or pointing it in a different direction, or just simply sliding it or gliding it around the coordinate plane. All right, next up, we're going to look at some words. Pre-image is the image you start with. So like when I go into the DMV, they take a picture of my face. My face is the pre-image, and the picture that they take, which appears on my driver's license, is the image. So pre-image is basically the original, and the image is the transformation, the copy of it. So one of the first transformations we're going to learn is one called translation. So in the world of transformations, the word that this is one of them that we're going to learn. This is called a translation. Another one will be reflection and rotation. So this is the first of the transformations that we're going to learn. Translation. So basically, this thing here is called a vector. So you're going to be given a lowercase letter with an arrow over it, and then you'll be given what looks like a point, but if you take a closer look, you'll see it has kind of carets on the end versus the soft brackets a point would be talking about. Okay, so this right here is giving the information about how you're going to move an object about the coordinate plane. So that A and that B comes over here, and we say, okay, so you take the pre-image, and you're given some point X and Y, and the number that's in the A spot moves it left or right, and it's pretty predictable. Left would be a negative number, right would be a positive number, and then up and down gets handled by the second letter, which is B. That's called a vector. And so let's take a look, see if you can identify. Here's a point, we'll call it A. Point's at -6, 6, and I want to apply this vector to it, 4, -2. Now simply go to that point and walk it over 4 in the correct direction, and then -2 in the correct direction. See if you end up with the point like I do. Put me on pause and come back and see if you got it right. Okay, so in other words, I'm going to take a point or my pencil. I'm just going to move it over 4 and then down 2, right? And that will get me to the point -2, 4. It's really quite easy to do this without even having a coordinate plane. See, if I take the 4 and add it to the -6, I get that -2. And if I take the -2 and apply it to the 6, I get a +4. So that's all you got to do. Now, if you look at the rule over here, I just applied it. Given some point, X and Y, I can map it to a new point using the vector by taking X and adding A, and taking Y and adding B. Now, this is one way that I'll tell you how I want you to slide or glide or translate your object. They're all the same word. They're different words meaning all the same thing. This is another style of telling you that same information. Now, if you take a look at this way of writing it, that arrow there is a single line with an arrow on it. This is different than we used in the conditional statements, which was 2 lines with an arrow. This single line with an arrow means map xy gets mapped to, excuse me, it's saying take the point xy and map it to a new point that's found by taking your x and adding the a and taking your y and adding the b. Pretty easy. Okay, next up is the transformation called reflection. And so we're going to be reflecting points and pictures and stuff across different lines. In this case, this very first one, we're going to reflect it across the line known as the x-axis. So basically, when we reflect across the x-axis, which is this green line here, if we take a point, say 2, 3, and we reflect it to the other side, it basically, if you look, it takes the x and the y and it keeps the x the exact same, and then it takes the y and turns it into the opposite. And that's what I wrote here, right? It makes the y become the opposite sign. So there's the reflection of 2, 3. Now, one of the things I like about reflection is that when I'm given numbers like 2 and a 3 or whatever, the reflection always has that 2 and 3 embedded in it. It's not all of a sudden 10 or 12. Like when you're doing translations, when you're doing glides, given a -6, 6, when you apply this transformation, you get completely different numbers. But in reflection, the numbers will still be there, but they might be flipped, change positions, so the 3's here and the 2's here, or it becomes negative, okay? That's in the different types of reflection. The reflection we're looking at right now is simply across the x-axis, which means you take the y and just change the sign. Next up, reflecting across the y-axis, right, which is this line. So see if you can do this one. Take -5, 1, and reflect it. See if you can figure out what should happen to your point to get it to reflect across the x-axis or the y-axis. Come back and check your work. I'm hoping that you said it was 5, 1. You put a little thought into it, you put it on pause. And so basically the idea here is when you're taking a point, let's say it's x, y, and reflecting it across the y-axis, you simply change the sign on the x value. So this rule is it makes the x become opposite sign than what's given. Now we're moving on to reflecting across y equals x. Okay, so we have y equals x. Get that out of there. Cool. So we need to know how to draw y equals x. This is an Algebra 1 concept, and a lot of students come in and they don't know it. And you're just going to have to memorize that that's y equals x. Basically, you go up 1, over 1, put down a point. Go up 1, over 1, put down a point, and you've got this line. Okay, so now when we go to reflect this point, in this case, -2, 3, we reflect it across this line. So it's going to be the same units on the other side. And if I'm working with graph paper, it's relatively easy. Just simply count perpendicular to the line and then put it over here. Now keep in mind, these reflections that we're dealing with, the numbers are going to be embedded in it. So it's still going to have a 2 and a 3 someplace in the answer, but it might be they've switched positions, they might have changed signs or whatever. Basically what ends up happening from the rule is given some xy, map it to yx. So simply take this point and flip their position. So I end up with 3, -2. All right, let's move on to reflecting across y equals -x. Okay, so it's just like the y equals x, but it has a negative slope, so we draw it the other direction. So for this one, you take it and it changes the sign and the position of the x and y values. Okay, so given some x and y, to get its reflection across y equals x, you have to change the position and then make them opposite sides or opposite signs. And then the last one, when we reflect, as they say, in the origin, on the origin of 0, 0, the rule is you make them both opposite in signs. So given some coordinate like, let's say, 2, -4, don't change their position, but that one maps to -2, comma, +4. So you just change their signs. All right, let's turn to the next page. And so for this, we're talking rotation. Okay, so rotation is usually in the coordinate plane. And when we're talking about that, we'll be taking an object, let's say, in the coordinate plane, and we'll rotate it 90 degrees. So just imagine it being here, and then we'll rotate it 90 degrees. Okay, and that would be a 90-degree angle there. So we're going to need to have some rules possibly for that. I have a quicker and easier way, but let me go ahead and get this formality out of the way. Positive rotation is counterclockwise. That's probably different than you thought. Counterclockwise is this direction. So that's positive rotation. Negative rotation is the other way. Okay? So that's negative direction. This is positive. Now for me, that's opposite than what I thought. So let's just talk about why it is that way. If you remember in the coordinate plane, the top right-hand corner is coordinate 1, and then it goes 2, 3, and 4. So if you look at it from that perspective, it makes sense that as you go this direction, the numbers, the coordinate numbers start to go up, and that would be a positive direction of rotation. So now we have 90-degree rotation, and there's a rule for that. You just take it, you flip the coordinates, and you change that one to an opposite. And these are just here as a formality. I have a much easier way for you to do it if you follow me. So this is what I call the flip and force. I'll show it to you in the lesson when we get there. For now, just write this in here for reference sake. What you do first is you flip the x and y every 90 degrees. So if it was x, if it was 3, 4, when you go into the next quadrant, it becomes 4, 3. But of course, the sign will change. So what ends up happening as we go through this, you'll flip the numbers back and forth every 90 degrees. And then when you land in the quadrant that you're supposed to be in, you'll make the signs fit for that quadrant. The x's in this quadrant are positive, and the y's are negative or whatever. Okay? All right, let's take a look at dilation. Dilation is basically a transformation. It takes objects and makes them larger and smaller. Now the notation here is dk takes the point xy and moves it to dx dy. Okay? Now, quite honestly, I think that should say kx and ky. So if you'll fix that on there for me, I'd appreciate it. Okay? So basically what it's saying is, let's say I have d5. And k is 5 here, and you have some point x and y. Well, that maps to 5x, 5y, so I just multiply them. Now, if I want to make something, that makes something 5 times as big. If I want to make it half the size, I take each piece of the each point, and I multiply it times a half, and it moves it closer to my dilation point, but it also makes the entire image smaller by 1/2. We'll see that as we get to that unit. Point symmetry is basically if you can rotate a figure about a certain point 180 degrees, then it maps back onto itself. Okay, so that's called point symmetry. So let's take a look at this object here real quick. Suppose I have this pentagon, and I was to take another pentagon exactly the same size and put it on top of it. I'm going to put that arrow on top of it just so you can see it. And when I say see it, I mean the rotation, right? So what I'm going to do is I'm going to take that shape and start rotating it. Now, because of my smart board technology, it doesn't rotate it right on the center. It has another point of rotation, so I have to readjust it. But 180 degrees, if I'm pointing at the top, north, 180 degrees is pointing it to the south. Hopefully you can see that does not line up with the black object in any way. So that does not have point symmetry. All right, let's take a look at this hexagon. If I take this hexagon and rotate it 180 degrees, right? Bring this down. And whoops. Okay, I have to readjust it because of the way my smart board technology rotates. All right, so as you can see, it rotates right back onto itself. So that is an example of something that has point symmetry. Let's look at line symmetry. Line symmetry is basically anything that if I drew a line on it and folded it on that line, whatever's on one side would appear on the other. Okay, so if you look at that, that's a line of symmetry. If I folded it, the top part of the triangle would match the bottom part. Okay, and so here's another line of symmetry because if I fold it this way, same thing happens. All right, that's pretty much it. So go ahead and have a fantastic day.